Now we can go taller with gravity walls by just creating these extenders or anchors to the back of the block. Pardon me?
Dead man.
Dead men. Yeah, it's sort of a dead men concept, what you would do with a railway or a wood kind of a wall. Yeah, absolutely. So we get a little bit of deeper base. Now we can start going taller with our walls. We can get really, really tight to any kind of rock outcropping. We can get tighter to the property line. Properties are getting more and more costly, and people want to make more and more use of all their land. So we as contractors or engineers and developers, we have to try to find ways of how we can get closer to property lines. This will allow us to do that. With a gravity wall, we can be about 0.4, 0.5 H. So if we're 0.5 H, that means that we're about 5 feet deep or 6 feet deep for a 12-foot high wall. All right? Whereas if you're going to a geogrid wall, you'll probably be closer to 0.7 or 0.8 H. So that's about 2 to 3 feet of excavation we don't have to do. That's 2 to 3 feet that we can be closer to our property line. So it becomes quite significant in some projects. That land, that strip of land becomes valuable, and they're willing to pay the extra dollars for a gravity wall rather than excavate and spend that money on that area. So we can do a 2 foot or a 4 foot, and then we can chain them together. One of the advantages, this is a project in a railway rapid transit system in St. Louis. What we actually had to do on this project, we did a seismic or earthquake simulation loading on that wall in order to simulate what would happen when rail trains came by at rapid speed, the vibration from that. You can see what the advantages are of doing a gravity wall. We can get our surfaces right behind the wall rather than cutting through the grid. We don't have to deal with that. We can be closer to that back of the wall detail, especially when they're going to go back and do any kind of service repair. Through wall details going through, all of this area from the back of that extender into this area should be filled with clear crushed gravel. It's easier to work with. It doesn't mean that you couldn't use some other on-site materials, but it's harder and harder to compact in that zone. It's very difficult to get a compactor in there and do a proper job. So I would suggest that all this area always get filled in with just clear crushed gravel. But then I would also cap that with a fabric as well. Remember, anything vertical, anything horizontal, I would use a fabric to separate soils. Some projects that have been done with gravity, nice coping cap on top, returns on the edge. We can also start chaining these things together and go taller and taller and taller with these gravity walls. I think we've done some walls that are around 22, 24 feet tall with gravity, and we're designed one now that's around 28, 30 feet tall with a gravity system like this. So there are more and more needs for this kind of a project. And you can see that we step it back shorter and shorter as we get taller, and we make sure all of that area is filled up and the filter fabric gets separated, is moved across just like that. The fabric is separated, the gravel from the backfill zone. And again, step your back cut. It interlocks that whole system into place. And here you can see some projects that have been done with the extenders. This is 8 feet versus 14 feet. It's just a little over 0.5. And these are some of the bigger, taller gravity systems, convex, concave curves. some pretty nice projects that have been done with the gravity system.